Okay, in this video, let's see what does the concavity have to do with the second derivative. Um, Now, in the previous video, we have seen that if the first derivative is increasing, then the function is concave up, and if it is decreasing, then the function is concave down. So we can summarize like this. Okay. So the first derivative is decreasing, then the function is concave down. Okay. Now, in the previous section, we learned that when the first derivative is increasing, we learned that when the first derivative is a positive, then the original function gonna be increasing, and if the first derivative is a negative, then the original function is decreasing, right? Okay. Because the derivative of the first derivative, now let me see this again. The derivative of the first derivative is a second derivative. So using this result, if the second derivative is positive, then the original function, here the original function of the second derivative is f prime. Using this result, the first derivative gonna be increasing and the function gonna be concave up. And if the second derivative is negative, then the first derivative is decreasing and the function is concave down. So this is the relationship between the concavity and the second derivative. If the second derivative is positive, then the first derivative is increasing and the function is concave up. And if the second derivative is negative, and then the derivative is decreasing and the function is concave down. This is what we call the concave test. Okay, let's look at another example. So as I move the point, the tangent line, the slope of the tangent line is getting smaller and smaller. So the function concave down, and the second derivative is negative. And when I go here, the slope of the tangent line is getting bigger and bigger, and the function is concave up, and the second derivative is positive because the first derivative is increasing. Okay, and the inflection point are the points at which the concavity changes. And the critical point of the first derivative are possible inflection points. For example, on this graph, we have two inflection points. One is here, another one is here. To find the inflection point, we're looking for where the second derivative is equal to 0 or where the second derivative does not exist. Okay, now let us use what we have learned so far and to try this example. This problem gave us the graph of the derivative of some function. Okay, remember, this is not the graph of the function fx. This is the graph of the derivative of fx. This is the graph of f prime x. And we want to use this information to find the intervals on which the function fx is concave up and concave down, and then find the inflection point. Since we are given the information of the first derivative, and according to this, we know that when the first derivative is increasing, the function is concave up. When it is decreasing, the function is concave down. So I know I want to look at where the first derivative is increasing, which is from negative infinity to negative 8, and from negative 5 to 0. And the first derivative is decreasing when x from negative 8 to negative 5, and from 0 to negative infinity. So the first thing I'm gonna do is to create this number 9. Okay, and then write down all these numbers: negative 8, negative 5, and 0. Okay. So now the number 9 is divided into 4 intervals. On the first interval, the first derivative is increasing, and on the second interval, the first derivative is decreasing, and it's increasing and decreasing. Okay. Now, then I will translate this information into the concavity. Now, the function is concave up, and the function is concave down. And from negative 5 to 0, the function is concave up, and it's concave down. Okay. So the inflection point, they are x equals negative 8 and x equals negative 5 and x equals 0. Because the concavity changes at these points. Okay. Now in the next video, I will show you, if we're not given the graph, if we don't have any information about the graph or about the graph of the first derivative or second derivative, we're only given the equation of the function, then how to find the intervals on which the function is concave upward and concave downward.